What got me interested in algae is when I was in college, I had over five fish tanks. I had saltwater aquariums in college. And what we found was that as the aquariums were fed more and more food, it was difficult to clean the water efficiently. So algae helped support the ecosystem by absorbing that pollution and growing and turning into biomass. The problem, of course, is that in an enclosed system, the algae kept growing and I could never find an end to it. So no matter how much I cleaned, no matter how much I scrubbed, the algae grew back faster and faster. And it dawned on me one day, why don't we utilize this incredible growth rate of algae to be able to produce renewable products? And so if you look at an algae cell, one of the reasons that it's so amazingly efficient is that, with a tree, you've got to produce roots and bark and limbs and leaves and flowers and fruit. And with algae, there's none of that. All the energy that it's absorbing and transforming through photosynthesis is being duplicating itself. So it's turning into additional cells at an incredible rate. Algae can duplicate itself in less than 24 hours. So as far as a photosynthetic organism, it is the fastest, most efficient photosynthetic organism that we have on planet Earth. And it represents an enormous class of different microorganisms. So we see green algae, blue-green algae, diatoms. These biomasses, these cells have this incredible growth rate, and they've been doing this for millennia. And what we find is the scientists are saying that the petroleum reserves that we have under the ground are actually ancient algae beds that have been converted through pressure, heat, and time into what we call crude oil. So what we're trying to do at Algae is accelerate this time frame. Let's grow algae today that we can use to produce crude oil, bioplastics, foods, feeds, fuels, a variety of products, but we can do it with new carbon, with new pollution, as opposed to relying on the emissions from the past.